I came across this tweet the other day, which piqued my interest for a couple reasons. One, it's from Mike Bostock, who's the creator of Observable and D3. And second, it's this really terse piece of JavaScript code, which I noticed makes use of this audio context API, which is a web API that's built into all web browsers and allows very basic usage of audio processing in the browser. I let my interest and curiosity get the best of me, and I opened up my developer tools, and I pasted this bit of JavaScript code, which when you execute it, has this very fun Mario chime, which many of you might be familiar with. And so I thought it might be fun to record a video where we can take this piece of functionality and bring it into a Jupyter context, and how I would think about exposing this fun piece of code that Mike shared on Twitter behind a Python API. And we can go through many of the steps of actually building out how to interact with this small piece of code from a Python perspective. The video today will go at a very high level for how I would prototype something like this. And at the end, we'll have a nice, fun little widget that we can publish to PyPI, and I'll post to GitHub so that you can look at the source code. So let's hop right into our terminal. So I'm going to create a new repo that I'm going to call ipymario. I'm going to cd into ipymario. And then the first thing I want to do is just make a Python environment. So you could start prototyping a full Python package, but I like sometimes to get started with these pieces of code just in a little Jupyter notebook. And then if I have something working, I transition into a more robust sort of Python package. So I've been using this new UV command from the Astral folks for bootstrapping Python environments, just create a new virtual environment. So activate our new environment, and then I'm just going to pip install anywidget, Jupyter Lab, and some key bindings. After we have that installed, we can launch Jupyter Lab, and we can hop right into starting to prototype this. So the first thing I like to do in one of these notebook environments is actually go to anywidget.dev and copy and paste this example. This example really serves as a nice starting point to all the pieces that you might need in a widget. And I'm just going to rename this to widget. And at the bottom, we can create and render our widget. So now when I click this button, we have a piece of widget state, and if we save this widget to a variable, we can set the value of the count here. So this is already a widget that you can create and share with anybody, but we're going to now strip out some of this functionality and start adding in this piece of code that we found online. The first thing that I'm going to do is clear out this cell, and I'm going to take Mike's code, and we're going to bring that into this function. So I'm going to get rid of creating this button and appending the button to the DOM, and instead, all that I want to do is just get this piece of code to run. So it's a huge piece of JavaScript. It might be a little bit hard and terse to look through. So I'm going to just start trying to break this up so we can actually read it. Okay, so now I've moved this code over. You can see kind of how this API is getting used. I noticed that it creates some audio context. It sets the gain. I think it creates this oscillator. I don't really know what these APIs do, but we can start to maybe pull out pieces of this function and use this on our own. So with that, we can save this notebook. I'm just going to call this demo.py. And when we run this notebook, hopefully we hear this noise. Okay, great. So we were able to sort of de-obfuscate this piece of code from Twitter that now we can start extending on top of within this Jupyter environment. I know that this bit of code makes this chiming noise, and maybe what would be a good starting point is actually extract this into its own function. So rather than calling this within render, which is specific to any widget and gets called anytime our widget is displayed on the screen, I'm going to move this into its own function. So I'm going to just go up here. I'm going to create a function that I call chime. And then at the bottom, we can just call our function within render. So I've moved this code around. That's all that's happening. If I run this again, we should hear the sound, and we've just sort of abstracted those pieces out into a function. Right now, in order to trigger this chime, it happens anytime that we just render or display this custom widget. So if I don't actually display this widget and we run this cell, you won't hear the noise. But if we display the widget, and maybe it's easier if I demonstrate that this way. So if we do inner text, we can say, "It's me, Mario." And if we run this, you can see that we get the text and we had that noise. If we don't display that, render never gets called, so we don't hear the noise. We have our little bit of text, but right now there's no way to call this piece of JavaScript code or trigger it with some sort of event. Like it's just the event of actually displaying the widget is what makes it make the chime, and maybe it'd be nice to have like a little button that we display that you can click, trigger this function. We can do that first by creating a button element. So we can say button equals document. And then within here, we can set the button's text to be click, or it's me, Mario. And then we can add an event listener to this button that calls chime anytime that we trigger this event. So we can say button add event listener click. So we're going to listen for any sort of click event on the button. And within this event listener, we can call chime. So now we're creating a button, we're setting some text on that button, and anytime that we click that button, we're going to call the chime. And then the last thing that we need to do is append this button to the element that we get back from anywidget. So this element corresponds to the actual output area for each cell. And what we're saying is add this button to that output area. If we run this cell, we should see a button, and when we click that button, we should hear our noise. This is really like the bread and butter of creating an anywidget, is just that you start to expose both interactive and Python bindings to calling some of these functions that you maybe have on your JavaScript side. And so they can either do something like this that calls a web audio API, or do some fancy rendering with other APIs, maybe built around something like Web GPU or Web Canvas. And it's really just this binding layer that connects these two worlds. The next thing that I noticed about this function is that it can sort of be parameterized by different pieces. So we notice that we're setting some different values here. I don't really fully know what this does, but I've noticed that there are maybe two things that we can bring out and expose to the Python side to be able to configure from Python. Rather than chime being a function that takes no arguments, we can add two pieces of state. So one could be the gain and the actual value, so how loud this will end up being. And then the other we can call duration and how long the sound is. And I've looked at this piece of code before, so I know that setting G here is actually setting the gain. Maybe we can actually simplify this a little bit. So there's a little bit that Mike Bostock did here to reduce the number of values, but it makes it a little bit harder to read. We can set the duration. And so now when we call chime, chime requires two values. It's going to get the gain, which maybe we say is 0.1, and the duration, which we say is 1. So now we call this and click this button. We hear that function again. If we set the duration to be very long, so maybe 2, and run this again, you hear it's much longer. And if we set the gain to be 0.3, I don't want anyone's ears to get hurt with this, but we can run it again, and you hear it's a little bit louder. All of this state currently lives in the JavaScript side, and we want to expose this to the Python side. Within the render function is where we have access to both listening to changes from the Python side and sending changes to the Python side. And all of the state that we define on our widget is exposed to us in this function as well on this model object. Rather than having gain as being this hard-coded value, I want this to be something that I get back from my model. So I'm going to say model.get gain. And I want to do the same thing for the duration. We're going to do model.get duration. Now, rather than having those hard-coded values, we're asking for these particular values from the model that we've defined. And we define pieces of shared state as traitlets. So here I'm going to create a value called gain, and rather than it being an int, it's going to be a float, and its default is going to be 0.1. And this tag sync metadata property tells IPyWidgets to synchronize this value between Python and the front end. And we're going to repeat the same, except with duration, and we're going to make duration be 1.0. Now we both have gain and duration are these values that we can update on the Python side, and when we click our button, we should get the latest value for those. So if I run this again, you can see that we have our widget, and if I click, you can hear that value. But now if I say w.duration equals 2, rather than needing to rerun this cell or re-render this widget, I can just run this cell. It will update that value in the front end, and we can click the button. And you can hear it's longer. And if I make it really short, so maybe like 0.1, and run it again, this pattern of sharing state and synchronizing state is done through something called traitlets. But right now, in order to call this function, we need to click this button. Maybe on our widget class, we want to add a function that's called click. And the idea is that, I'm not going to code this up right now, but the idea is that when we have our function, we can call w.click or widget.click, And what that will do is it has the same effect as us clicking on the button, but we're triggering it from Python. And we have a special function on our widget Python class that's called send, where we can send custom data to the front end. So I call self.send. And within this function, we can send any piece of data that's JSON serializable to the front end. And so I'm just going to send a simple Python dictionary. I'm going to say the type. So I'm going to send a message with the type, click. And then on the front end, I need a corresponding piece of code to listen for these changes and click that button element anytime that happens. So on the front end, we listen for these custom messages through the model. So we're going to call model.on, and we're going to say message custom. And this gets a custom message anytime this function is called. And then within this function, we can inspect what this message type is. So we can say if message.type equals click. So we're getting back this object and we're saying, is the type click? And we know that when we have click, we want to call button.click. And that's it. So if I run this function now, we can click this button. It clicks the button, but also at the bottom, we can run this cell. And it also clicks the button because we have now added this ability to click via custom messages. You can now see that this ESM is starting to get a little bit larger. So as we start to add these features, this piece of code begins to grow, and it also isn't syntax highlighted. One thing that's nice in anywidget is that we can enable the ability to edit this front-end code without having to necessarily rerun the back-end code, and that's through something called hop module replacement, or HMR. That's a rather technical term. What that means in practice is that we can move this code to a separate file, and it makes developing a lot more enjoyable. In order to enable anywidget's HMR, the first thing we need to do is set an environment variable called anywidget HMR. And we're going to set that to 1 to opt into using this while we develop our widget. And then in order to use this, we're just going to create a new file that's called widget.js. And within widget.js, we're just going to copy and paste this piece of code. So I'm going to copy and paste this code in here. And I'm going to move that to this side of the screen. And then in this original file, all that we need to do is just say widget.js. As you can see, I haven't changed any code. I've just moved this code around. But now we have the same sort of functionality as before. And now the thing is, if I set the duration to be 2 and run this, you can hear it's much longer. And now normally if I were to make changes, I'd have to rerun the cell and I'd lose that state of the duration. But now if I say it's me, Mario, with some exclamation points and save this file, this automatically updates without us having to touch the duration. And the duration is still 2. So we haven't lost that state because we've only been adjusting some of the model state from the front end. We now have this button. We can set some of its state on that button and, play around with clicking it and doing some of these things. But what would be really nice, or what I thought of immediately when I heard this noise, is it would be cool if we could actually have a little Mario brick that we click on to trigger this noise rather than just a simple button. Rather than just sending like a pre-rendered JPEG or image or something, we could create that brick data using a numpy array and then send that data to the front end and render it into the canvas as an image. I spent a little bit of time before this video creating that brick data, but as a Python list. So if you squint close enough here, you might be able to sort of see the form of one of those question mark boxes from Mario. And our goal now is to convert this sort of string representation that I used to be able to sort of visualize what I was doing and convert this into an RGBA numpy array that we can send to the front end. I have beforehand also come up with a mapping of the correct colors. What you'll see is that I've used these different characters within this array, which then I want to correspond to these different colors. And then we can create a nice RGBA array to send to the front end using numpy. What that looks like is now we can create a numpy box. So I'm going to just say numpy box. And first, I actually think I need to pip install numpy. And I'm also going to just install matplotlib so we can see what we're doing. Nope, it's not a magic command. Just want to run that. We got our new dependencies, and then what should happen is up here I can import numpy as np, and then we can create a numpy array. So for our colors, we're going to get the current color for C in row, for row in box, and then we want our dtype to be a numpy.uint8. All that this is going to do is create this array, and we can actually visualize that with matplotlib down here. So import. Right. This looks correct, but currently this is now being rendered with matplotlib, and we really want it to be rendered in the browser. So I'm going to just delete this matplotlib. And what we're going to do now is take that numpy array that we have and serialize it to just its raw binary representation that then we can render on the JavaScript side using a canvas element and some typed arrays. I'm going to add another piece of state that I want to send to the front end, that is this box data, but I'm going to prefix that with a underscore because this is sort of a private piece of data. It's not something that I want to expose to the people that use this widget, for example. I'm going to call npbox.toBytes, and what 2bytes does in NumPy is it actually gives the raw underlying bytes for this piece of data that I created above. And that's nice because it's just a C-ordered contiguous array that JavaScript has used some utilities for us to be able to extract the data from without having to serialize to something like JSON. In the front end, I am going to just console, we can just say console.log model.get box. So if I save this and I run this code, and run this bit of code, we can open up the console. And now what we should see is if we run this model.got is not, and that's because that definitely is not a function. And what you'll see now is that we are getting back this data view, which is a JavaScript API, which provides very low-level functionality for reading binary data. We can get access to this raw underlying data we can create like a canvas element for and render some pixels. Rather than a button, let's change our button to a canvas element. Canvas. We're not going to have any text on that canvas. We're then going to add an event listener to that canvas. And we want to click the canvas now rather than that button. So we're no longer going to have a button. We're just going to have a canvas element that we render. If I run this bit of code, we should see that this disappears. And now we have this box. And if we inspect here, we can see that we have this canvas element now that we've created to the screen. And if I just click this area, we should still hear our chiming because we no longer have the button, but we've just moved all that functionality to target this canvas element. I know that this, if we look at the MP box, we can look at its shape. So we know that it's a 16 by 16 by 4. So it's 16 by 16 pixels and it's RGBA. So those are the 4 components that are in the third dimension there. We first want to size the canvas width to be 16 because I know that's a number of pixels, and also do that with the height. What we can also do is set the canvas style.width. This is different from the canvas width because the canvas style is sort of sizes how big our canvas is going to be. So we can set this to be something like 30 pixels, which is different from the actual number of pixels on the screen. We're going to set it to be 16 by 16, and then we're going to stretch that out to 30 by 30. So if we run this, we should get a much smaller output. But if I hover again, you should see we now have this 30 by 30 canvas here. So the next thing that I want to do is prepare a typed array, which is the RGBA value. So right now it's just sort of this opaque set of bytes, and we want to get a view of that data that we can give to a canvas element. So I'm going to call a variable bytes. We're going to create a new uint8 clamped array. And within this, we're going to model.get our box, get the underlying array buffer from that data. So what this is going to do, we can console.log bytes. If we save this now, you'll see that I actually now have this clamped array, which is 1024 elements, which is 16 by 16 by 4. We have like the data now, we just need to get this into something that we can put into the canvas. We can create an image data, which is new image data. And the first thing that this takes is our data. And the second thing this takes is the width and the height. So our image data is 16 by 16. The width is 16, the height is 16, and we have this piece of data now. So if we console.log this, we can do that again. We now should have our image data, which is 16 by 16, and the underlying bytes for that is this contiguous array. We now need to be able to draw those pixels to the canvas. So Canvas has this API where we can get something called a context. So we're going to get a 2D context where we can actually draw data. And it's going to put image data, image, and we're going to put that at 0, 0. So now what should happen is when we save this, perfect. We get this little box that now when we click this box, we hear our widget. And we were able to take data that was a NumPy array and put that as the underlying pixel values here. You could take this notebook, you could play around with drawing your own grid, and that would replace the elements that you see here on the screen. It would be nice to have a little animation, right? Like when I think of Mario, you jump and you sort of knock the brick up, and that's when coins come out of the brick and the noise comes. But right now when we click this, there's no visual indication that we've clicked this brick. Fortunately, with anywidget, this is really easy. We can add a new file that's called widget.css. And within widget.css, we can start adding some CSS rules for how to define animations. So CSS has an animation API where we can animate some of the styles on this element. So rather than needing to write JavaScript, we can actually defer a lot of that animation to the browser to do something kind of fun. The first thing that we want to do is make sure that we can write styles that are scoped to just this element. By default, they're cascading style sheets which can conflict with one another. So within my widget, if I were to start styling a canvas element directly, the styles wouldn't be scoped and they affect other canvases on the page. So we want to make sure that we are adding styles which are scoped to a particular element. If you aren't adding that many styles, a really easy way to do this is to add a custom class onto the root element and then scope styles for specific elements within that. So this is a selector that says any child of PyPI that's a canvas, apply these styles. And then here, what we're going to do is element class list dot add, and we're going to call it PyPI. So we're going to save that. We don't see anything so far, and that's because we need to add widget.css. Oh, I'm sorry. So the first thing I'm going to do is just add some padding. So we can say padding is going to be 12. If we save this, we should see some padding. We can make this a lot bigger. As I save this, you'll see now we got a ton of padding. Just want to give us a little bit of room so that when we have this animation, we don't clip the box as we make it jump. So the next thing that I'm going to do is add a keyframe so that we can perform some of this animation. You don't need to know the details for this, but I wrote up this little animation I call PyPI bounce. It applies a keyframes transformation from CSS. And so what this does is we'll get the effect of this jumping just by applying and removing these keyframe styles. I need to add a really basic is both. So this won't do anything so far, but then within our click event handler, what we're going to do is set the canvas.style.animation equals none. This is going to clear off any animations that we're currently doing. And then we're going to do this trick, which is a set timeout. We can apply that animation by doing canvas.style.animation, and we're going to set that to be our PyPI bounce, and we can set that to do 0.2 seconds. So that's going to be the duration of our animation. And the trick here is that if we were to set animation like this, clear the animation and apply our new animation, this JavaScript code gets executed before the browser actually has a chance to render. So we would never apply like the none before here. What this allows us to do is sort of defer the second call to after this has rendered. And this is just a common sort of JavaScript trick to trigger these types of animations from JavaScript. And there's plenty of stuff online about this. So now we're applying our keyframe animation and removing it anytime we have a click event. So now if I've done everything correctly, we should have a little fun widget here. So if I click, we have this nice event, and if I run the click event from the Python side, we also trigger this nice animation. To add to this, there's a lot of ways that we could extend this, but we could say that size, we actually want to get traitlets int. So right now it's a number of pixels that are in our box, but we might want to change the size of this element and allow that to be something that they can scale from the Python side. So we can say, I want to add size equals true. And then on the JavaScript side, right now we have this size sort of hard-coded here. And I'm just going to add a helper at the top that's called size. And this is a function that we get back, model.get. And then here we're going to just set this to be size. And then at the bottom of this function, we want to listen for any time size changes to apply like a resize. We can do model.on change size. So this is going to listen for the size changes. And then I'm just going to hop up and grab this bit of code. I'm realizing I typed in the wrong thing up here, so 16. These can stay hard-coded. Sorry. And then here is going to be size and size. And we're going to grab that bit of code and bring that down here. So now anytime that we change the size of this element, it should work just fine. So now on the Python side, if we run this, we should get our element. And now if maybe we say that the size, we want this to be 100, and we run that, it should grow in size. If we set it back to 30, it should shrink in size. Another piece of state that we could add here is something like animate. So maybe we want to be able to disable animations. So we could say bool, and for our animate, we could say by default this is true. And now on the JavaScript side, if model.get animate, so if we have animation set, then run our animation. Now we have sort of this animation effect that we only are applying at time. So now if I click, we should see the animation, but now if I set the animate is equal to false and run that cell, we now shouldn't see the animation. So the last thing that I want to do is, we've prototyped this whole thing, we have it in this notebook, but now maybe I want to actually share this on PyPI or publish this online in a way that someone else can use. So right now, all of this prototyping has been happening in a notebook, but we can start to actually turn this into a Python package where we can share this functionality. I'm going to switch over to the terminal now to show how to bootstrap a project that's ready to put to GitHub and also publish to PyPI that people can pip install this IPyMario widget. We're in this directory where we have our virtual environment, our demo notebook, and our front-end files that we've just been playing around with in Jupyter Lab. And the first thing I'm going to do is set up a Git repository. So I'm just going to git init, and this will create a Git repository. And I'm also going to add a git ignore file where we have our VM. And also, because I'm on Mac, I'm going to just put the ds store in here. Okay, you can add our files, and we're just going to add our initial commit. And then the next step is that we're going to set up anywidget CLI so we can bootstrap a project template that's ready to publish to PyPI. So I'm going to run npm create anywidget at latest. And what this will do is it'll ask a couple questions about our widget project. So we want to create this widget project in this directory. Our directory isn't empty, so yes, we want to confirm this, but we also ran git commit earlier so that we can revert anything that the CLI does in case it messes up something in our directory. Finally, it's asking what kind of framework that we want to use. We don't have a framework, so we're going to click vanilla. We also don't futz with any bundlers, and we don't have any dependencies, so we're just going to choose this minimal JavaScript template. So I'm going to hit enter, and this will create a few files in this folder. So you can see we now have source directory and some other things. This directory in my file picker, and we're going to move around a couple of different files. So I like type checking a lot of my code, which is why this dino.json file is here. But for this project, we really don't need this. It's not required for publishing, so I'm just going to remove it. We have our own example notebook with our demo notebook, so I'm also going to remove example and move these JavaScript files that we have into our project structure. So we have the source directory, which has the static folder where it keeps the two widget.css and widget.js, and we're just going to replace those with the code that we've been writing. So I'm going to replace the widget.css, and I'm going to replace the widget.js. And then in our pyproject.toml, we want to add numpy as a dependency. So this is specifying the dependencies for our project, and we have anywidget, and we use numpy. And now that we have all those files set up, I'm just going to run uv pip install -e with our development dependencies to make sure we have this development version of IPyMario installed. So we can test this by running import IPyMario, and we don't run any errors, so we correctly set up this environment. So next bit that we're going to do is jump back into Jupyter Lab and start actually moving around the Python source code into our project. We have our Python code currently lives here, and I want to now jump to IPyMario and start editing this Python file. What we can do is copy this numpy dependency and bring this into the top of this file. We can then copy our sort of the brick source code into this file as well. So now we have that piece of code that sets up the actual image that we render in the front end. We're just going to copy the rest of this class. I'm just going to leave the ESM and CSS because those point to the correct static file paths, and the last bit is just going to be changing this to widget. And now within our notebook environment, we should be able to import from IPyMario. So import IPyMario, and down here we can do IPyMario.widget. If we've done everything correctly, our widget should show up. Now package install rather than just sort of this incremental notebook. And now when we click, our animation should work. We should be able to turn it off, and we can click it from here as well. Now that all these pieces are in place, let's jump back into the CLI and publish this thing to PyPI. So I'm going to close the Jupyter server, and then from within here, we can run hatch build, which will build our project, and we can run hatch publish. So now we've published to PyPI, and the reason this worked is because I've already authenticated to PyPI but we can go to this URL in our browser, and we should be able to see our package on PyPI. So that was a very basic overview. I will touch up this README with additional information and also link back to this video, but I'll also link this project in the description of this video if you'd like to tweak around with your own iFi Mario widget of your own and play around. So thanks for watching, and best of luck coding your own widgets.